So this is the third video that I have here on my YouTube channel that deals with immunity. The first video I had was covering what we call the non-specific immune response. These are things like your skin and mucus and fever and how your body starts this whole immune response in order to fight off these pathogens. The second video focused on what we call specific immune responses, things like the police department, which is our B cells or the humoral response, and the fire department, which is our T cells, which is what we call the cell-mediated response. This video is going to deal with what does immunity mean, as well as different immune disorders that we find in humans. So immunity doesn't mean you're never going to catch that pathogen again. Remember, pathogen is any disease-causing organism, and your white blood cells don't know what a bacteria is. They don't know what a virus is. They just know that they don't belong to you. We all have a special protein on all of our cells called the MHC protein, or the major histone compatibility protein. And this is what your immune system is looking for. It's looking for your special protein. So when we talk about immunity, immunity doesn't mean that you're never going to get the chickenpox virus again, or you're never going to come in contact with flu 2020 again. It just means that you're not going to develop the symptoms again. Because what's happened with immunity is this is a resistance to a disease-causing organism. So all of us come in contact with the chickenpox several times a week, but we don't develop the chickenpox symptoms because we've already been exposed to that virus. We either had the chickenpox as a child, or most people in today's society had the chickenpox vaccine. And so what our body has to do is what's called the primary immune response. Okay? Anytime you get sick, you are facing a pathogen that you've never seen before. And your body's having to go through what we call the non-specific immune response and the specific immune response in order to fight that guy, figure out what it is, destroy it, and make these things called memory cells. So everybody listening to this video has either had the chickenpox or the chickenpox vaccine. So you have memory cells in your body whose only job for your entire life is to look for the chickenpox. So when you come in contact with the chickenpox again, it's just like having police officers with mugshots. So you have one police officer in your body whose only job is to look for this one bad guy. And so when the bad guy shows up, it can immediately be arrested before it causes problematic symptoms inside of you. Well, we have to develop memory cells. So we have what we call the primary immune response. Primary means the first time you've ever seen that pathogen. So the very first time your body ever sees chickenpox, you either had chickenpox or you had a vaccine. When you have a vaccine, vaccines are for viruses. And when you get a vaccine, you're actually getting parts of that virus. Now, it's been mutated so it can infect you, but your body doesn't know that. So when you become a parent and you have your child is given a vaccine, the doctor will tell you they might develop a mild fever or they might not feel good for a few days. So once your body has fought off this bad guy, it's just like you've caught the robber, you're going to take a mugshot and you keep that on record so that if it ever shows up again, well, you had to catch the bad guy in the first place. So this is what we call the primary immune response, and this is when you actually get sick because your body has to figure out what it is that's attacking you. And so it takes time, so your body is going to create these things called memory cells. Now, anytime you come in contact with this bad guy again, you are going to recognize it. And so it's just like you've got the mugshot, like, oh, okay, well, I know that this person isn't supposed to be here, so we're just going to go ahead and deal with it. And so this is what we call the secondary immune response. So this is the second, third, fourth, thousandth time that you've had this pathogen. So since you have these memory cells, diseases, pathogens that you already had are not going to get you sick again. This is why it's incredibly important for children to get as sick as they possibly can. Daycare is your best friend and worst enemy. So if you have children and you go to daycare, you'll find that they get sick a lot, but they don't stay sick for very long. That's because their bodies can rapidly fight things in most cases. And the sicker you are as a child, the more memory cells you're going to have. So the less sick you'll be as an adult. So most of us, if you ever get sick, and if you think about it, we don't get sick that often. Most of us might get sick like 2 or 3 times a year. That's because most of the things out there in nature, our bodies have seen already. And so we have memory cells to fight them off. So primary immune response happens after you've gotten sick. That's when you're making memory cells. But you're infected a lot more than you realize because your secondary immune response takes care of all the problems for you. Now, how can you become immune to something? The first thing is what we call active immunity. With active immunity, you have to create the antibodies. Now remember, cells have proteins on their surface, and those proteins are called antigens. Think of them as shapes. We make antibodies, which are weapons that we use to stick to the bad guys, but they have to stick like pieces of the puzzle. So with active immunity, your body has to somehow come in contact with the bad guy. It could be you just get sick, or it could be that I give you a vaccine, or I somehow expose you to this bad guy. And so you're going to get exposed, and you're going to fight it. You won, and you remember it. So you're going to take the antibodies that you have, figure out which antibodies work best to block the bad guy so it cannot attach to your cells or infect your cells so that they can be destroyed. And you're going to remember what that bad guy looks like. You're going to have memory cells. So with active immunity, you had to get the pathogen first. So again, you either got sick by natural causes or a planned exposure, which is something like a vaccine. Okay. So you detected it, you eliminated it, and you remember it. Now that's different from what we call passive immunity. Now passive immunity doesn't happen for most people who are listening to this video because we're not infants. With passive immunity, you don't produce the antibodies. If you think about it as a fetus, the mother's immune system is taking care of any infection that might be taking place. So if you think about it, it's really amazing that when infants are born, they don't immediately become sick. You know, here they are breathing in air for the first time. There's microorganisms crawling on their skin for the very first time. If an infant becomes sick, doctors really get worried. But if you think about it, like I said, it's amazing that infants don't get sick. That's because infants have what we call borrowed immunity or passive immunity. In this case, mother is going to pass on certain antibodies through the placenta. And this antibody will protect the baby for a short period of time. Now, antibodies are made of proteins, and over time, proteins will denature, they will wear out. So over time, the mother's antibodies will just basically get old and fall apart. But hopefully by then, the newborn has started producing its own antibodies. Now, like I mentioned, a vaccine is when we expose you to a virus. Now, vaccines are for viruses, V's and B's. Okay? Vaccines is an exposure to the virus, but that virus has been mutated, so it can't really infect your cells, but you might still develop, like the achy, a little bit of a fever, runny nose, because your body is trying to figure out, okay, what is this? But once you've had a vaccine, you've made the memory cells for it, and so therefore, hopefully you are now immune to that virus. Now, vaccines and antibiotics are different. Vaccines are V's for viruses, antibiotics are B for bacteria. Vaccines will stop you from getting a virus because it builds your immunity. Antibiotics won't stop you from getting bacteria, but it will help destroy those bacteria. And the number one type of antibiotic, or the very first antibiotic discovered, as you guys know, was penicillin. And the way that antibiotics work, most antibiotics are made from fungi, and fungi secrete chemicals that put holes in the cell walls of bacteria. So water rushes in and the bacteria explode. Now, for some vaccines that are out there, like once you have the chickenpox vaccine, you probably won't need the chickenpox vaccine again. But there's always a chance that viruses can mutate. So for example, that's why we have to have a flu vaccine every year, because the flu virus mutates so quickly that it's a whole different strain. And that's why the flu season has to start a lot of times before you can get the flu vaccine, because they have to figure out what kind of flu it is. So it really depends on the antigen. So again, some disease-causing viruses will mutate, while others seem not to. And so that's why a lot of times some vaccines you take once and you're done, but you might have to have like a little booster shot later on just to make sure that your body has the memory cells that they need. Now, in the case of immunodeficiencies is when a person is missing part or all of the immune system. So for example, we've got all these different types of antibodies. It's like having all these different types of puzzle pieces that I can use. So it'd be like you buying a puzzle and you're missing one piece. So some people might not make the star-shaped antibodies, or some people might not make the square-shaped antibodies. Well, if this is the case, you are deficient, you are missing part of your immune system. And it's very possible that immunodeficiencies are more common than we think because somebody just might be missing a certain antibody. But the most severe form is called SCIDS, Severe Combined Immunodeficiency Disorder. These people genetically have no immune system. So it's very sad because they start off as an infant being perfectly fine because remember they have that passive immunity. They have these borrowed antibodies which are called IgG antibodies from their mother. But then when those begin to denature, they don't have the ability to make their own. So they do die pretty young. But however, lots of steps have been made in trying to help these people. Now with immunodeficiencies, your body does not make a certain part of the immune system. In the case of acquired immunodeficiency syndrome, which as you guys know is AIDS, it acts like an immunodeficiency disorder. It is caused by the human immunodeficiency virus, HIV. It was discovered, and when we say discovered, since the 1950s, we've had this disease on the radar. But a lot more was actually learned about it, and the name was changed in the 1980s to AIDS. And we have a very, very, very special type of white blood cell in our body called a helper T cell. And helper T cells are the dispatchers. So like when you need help, you pick up the phone, you dial 911, and you talk to the dispatcher, and the dispatcher gathers your information, and it's the dispatcher that tells the fire department where to go, and it's the dispatcher that tells the police department where to go. Well, viruses are cell-specific. So think of a virus as a puzzle piece. It's only going to stick to another certain kind of puzzle piece. So like hepatitis can only affect liver tissue. Influenza attacks, respiratory tissue. Well, unfortunately, HIV attacks helper T cells. So without helper T cells, your immune system cannot turn on. It would be like you dialing 911 and nobody ever answering the phone. So HIV is a disorder of the immune system. People don't die from AIDS. They don't die from the HIV virus. They die from other diseases that get into their bodies because without the dispatcher, the police department, the fire department never realize that there's a problem going on. So because normal body cells are unaffected, the human immune system is not able to turn on. Now, we also have allergies. And allergies is when the immune system mistakenly recognizes harmless foreign particles as a serious threat. So, like I said before, when you need help, you pick up the phone, you dial 911. Well, when cells need help, they secrete a chemical you've all heard of called histamine. Histamine is the 911 call that our cells release when they are damaged. Well, in the case of allergies, there's nothing damaging your cells. But you have cells called mast cells that say, hey, I'm going to secrete some histamine. So it's like calling 911 for no reason at all. And so the histamine levels will spike, which triggers your helper T cells, your dispatchers, to call in the fire department and the police department. And these guys are running around. They have no idea where they're going because there's nothing wrong. And histamine also causes mucous membranes to begin to swell, which is why people with severe allergic reactions can have asphyxiation, where the mucous membranes in their bronchial tubes swell to the point that they close their breathing tubes. So this is why when you have allergies, you take antihistamines. Because when you have an allergy, your mast cells are making histamine and you don't need them to make histamine. So you want to stop the production of histamines. But if you're sick, do not take something like Benadryl. Do not take an antihistamine, because if you're sick, you need the histamine so that the police department and the fire department know where to go to fight off the bad guys. Then the last thing here, what we call autoimmune disorders. Autoimmune disorders are when there is a problem with your immune system. Remember, the cells in your body have this special protein on them that I call your marker protein. It's your MHC, your major histone compatibility protein. And nobody in your family has the exact same protein as you do. And this is how your immune system knows this cell is yours. And so this is why, for example, when people have organ transplants, they have to worry about rejection. Well, what happens is, like if you get a kidney transplant, your body's really excited because, oh, it's a kidney. But then your white blood cells, your immune system goes, yeah, but you're not my kidney. And so your white blood cells are doing what they're supposed to be doing. Since your marker protein isn't on that kidney, they're going to try to destroy that kidney. Well, in the case of autoimmune disorders, this is when your body destroys something that you're supposed to have. So your own body ignores your marker proteins and starts to destroy the tissues that are supposed to be there. So a prime common example is type 1 diabetes. Your pancreas has these cells called beta cells. And beta cells' job is to make insulin. And insulin is what kind of turns your liver off. Your liver feeds your blood, so like a faucet has to turn on and off. Insulin tells your liver to stop feeding your blood sugar. You're supposed to have beta cells. But for some reason, people with type 1 diabetes, their own body destroys those beta cells, so they cannot produce insulin. Another example is called Myasthenia Gravis. Okay? In the case of Myasthenia Gravis, your body will destroy these boutons that make something called acetylcholine. At the end of neurons, neurons have these special bubbles here that are called boutons. And boutons I always compare to water guns. Now, a nerve cannot touch a cell on the other side because we don't want to electrocute it. That's why we have this gap right here. And so when electricity hits this bouton, it shoots out this chemical. And this chemical is a hormone. It's called a neurotransmitter. And the hormone that we need to wake up our muscle cells is called acetylcholine. So with myasthenia gravis, we're supposed to have this chemical. But in one type of myasthenia gravis, the body destroys the nerve cells that make this type of chemical. And so therefore the muscles don't know to wake up, and the muscles don't know that we need them to contract. Another type will block the sites. So it's like if I were the nerve and you're the muscle and there's a glass wall between us, I would throw water at you, but the water hits the glass and bounces off. So it doesn't wake you up, so that your muscles don't know that they need to start working. Other classic examples are multiple sclerosis. Just like a cord in your house has a layer of insulation on it, our nerves have layers of insulation on them. It's supposed to be there. It's to keep them from short-circuiting. It's to keep them from shocking the other cells. So in the case of multiple sclerosis, your body destroys this layer of insulation, which causes these nerves to not function like they're supposed to. Graves, or some people say Graves' disease, this is an autoimmune disorder that destroys your thyroid gland. And so your thyroid gland makes lots of different types of hormones. So just depending on what part of the thyroid gland is damaged, it can have different effects. And then we have rheumatoid arthritis. In the case of rheumatoid arthritis, you are supposed to have cartilage between bones in a movable joint. This type of cartilage is called articular cartilage. It's supposed to be there to keep the bones from grinding together. People with rheumatoid arthritis, their own body destroys these bones, destroys this cartilage. And so it can cause the bones to grate up against each other. It can also cause the gap to solidify as if a broken bone was repairing itself.